In this presentation, I'll be describing the results of a 5-year longitudinal study of the impact of second language learning on the development of aspects of critical thinking, which we also refer to here as reflective judgment. This research was funded through a 5-year grant from the Federal Foreign Language Assistance Program. I'll begin by providing some background, then describe the sample and instruments, and share our methods and results. I'll close with a discussion, including strengths and weaknesses of the study and next steps. The formal mission of the Glastonbury Public Schools Foreign Language Department is to cultivate students' understanding and appreciation of other cultures as well as their own, and to empower them to communicate and participate successfully as informed citizens in a global society. Glastonbury School District serves approximately 6,000 primarily middle-class and upper-middle-class students, about 3,000 of whom are in K-5, 600 in grade 6, 1,100 in grades 7 to 8, and 2,200 in grades 9 through 12. The rationale behind this study was grounded in the notion that learning a second language is much more than learning new words to express familiar ideas. Anyone who's ever learned a second language knows that it also introduces new ways of thinking. These can be thought of as alternate perspectives on experience and the world around us. Asking students to consider and compare alternate perspectives is a common practice in critical thinking education, and second language learning, especially when instructors focus on the culture associated with a particular language, provides students with rich alternative perspectives to consider. Given this rationale, our research goal was to determine the extent to which second language learning in Glastonbury Public Schools contributes to the development of critical thinking. Our hypothesis is that second language learning supports the development of students' critical thinking skills. There was a total of 560 respondents in our sample, which was composed of several cohorts entering the study in grades 5 through 12. Sex was distributed pretty equally, with 284 females and 268 males. 25 students, less than 5%, were identified as in need of special education. 27 students received free or reduced lunches, and only 2 students were identified as English as second language learners. The vast majority of students, 456, identified as Caucasian, with only 46 East Asian and 49 students reporting other ethnic identities. The first instrument I'd like to describe is the LRJA, or Lectical Reflective Judgment Assessment. It is a set of disco tests, grade 4 to 12 assessments made and delivered online by Lectica, that are used to assess reflective judgment skills. The LRJA targets skills in several areas, including inquiry, evidence, learning in the mind, truth and certainty, conflict resolution, persuasion, and deliberation. Like all disco tests, the LRJA can be used for both summative and formative purposes, requires written responses to ill-structured questions that ask students to make judgments and then justify them, and is standardized to a developmental ruler called the Lectical Scale. This last feature, which requires calibration to a theoretically derived lifespan learning metric, is unique to Lectica and opens up many new possibilities for educational assessment, including the ability to show and compare student progress over time across a range of subjects. On the graph or report card shown here, the vertical axis is lectical level, and the x-axis is grade. You can think of the Lectical Scale as a common learning ruler for all disco tests. Values on the ruler range from 0 to 13, where 0 is birth and 13 is a level that's extremely rare in adulthood. In K-12, students typically develop through levels 7 to 10. Levels 9 and 10 dominate grades 5 to 12, and rate of development is highly variable, and development proceeds at different rates in different disciplines depending on the student. On average, students in grades 5 to 12 grow between 10 to 0.13 of a level per year, although the rate of growth gradually slows in higher levels. The ruler itself is based on Fisher's skill scale, 120 years of developmental research, and a construct called hierarchical complexity. It would take far too long to properly explain what all of this means during this presentation, but here's a very short intro to the idea of hierarchical complexity. The graph here shows a piece of a 5-tier model of development, starting with the representations tier and its 4 levels. Starting with level 6, which is associated with a single dot, we can move to 7, which shows 2 dots connected by a line, level 8, which shows 4 dots connected into a square, and level 9, which shows multiple squares connected to one another in a cube. These images represent increasing complexity and abstractness within a tier, with level 9 also representing the first level of the next tier, abstractions. With each level and tier, knowledge and reasoning become more complex and connected. Here's how we think about the implications for learning. Learning is a process of building connections in the brain. At each new level of development, we're constructing ideas using what we learned at the previous level and what we're being introduced to at the new level. Optimal development results from making many high-quality connections in every single level, so that each successive level can be built upon a robust foundation. Enough about the Lectical Scale. Let's get back to the LRJA. All DISCO tests are direct tests. In other words, they require students to provide written responses and explanations. This is essential because what we are measuring is students' productive knowledge and reasoning, how they can apply what they know. The questions shown here are those posed on one form of the LRJA, worded for 4th to 6th graders. There are a number of ways to think about the LRJA score. It can be thought of as an index of reasoning complexity in the domain of reflective judgment, or as the level of abstraction and coordination with which students can show us their thinking about ill-structured problems along targeted reflective judgment dimensions. It is not a measure of intelligence, factual knowledge, writing mechanics, or coherence. Also, individual scores may not accurately reflect capacity or competence, especially in low-stakes conditions. Many factors can affect the quality of individual tests. When it comes to determining capacity, it's best to observe performances on several DISCO tests over time. The LRJA is scored electronically with CLASS, our computerized lectical assessment system. Electronic scoring is monitored by human analysts through both random and targeted reviews. And CLASS is calibrated to agree with human analysts at least 85% of the time within 1/5 of a lectical level, which is the same degree of agreement we require of human raters. And by the way, anyone can now experience a free demonstration of the LRJA and CLASS at lecticalive.org. It's cool. You should try it. There are a few more things you should know about the LRJA. When we make a DISCO test, we study how students learn the concepts targeted by the assessment. This takes a couple of years. We then use what we learn to describe fine-grained learning sequences. This means that a score on a DISCO test explains what a student understands now and is likely to benefit from learning next. And when a student has taken an assessment multiple times, the assessment score tells how much that student has grown. Here on this slide, you can see descriptions of what students performing in phases 9 through 10C are most likely to benefit from doing next to improve their deliberation skills. The LRJA is associated with several sequences, one for each of its targeted constructs, including evidence and inquiry, conflict resolution, and truth and uncertainty. 2 other assessments are included in the analyses that follow, the CAPT and the CMT. These were Connecticut state tests at the time of the study and were administered in 2013. These assessments were conventional standardized tests of writing, reading, math, and science knowledge. And now we can move on to the results. The analyses that follow address two research questions. First, how are reflective judgment skills developing in Glastonbury schools? To address this question, we will look at growth over 4 years and compare the growth of Glastonbury students with the growth of students from other schools and districts. The second question is, does studying multiple language support the development of reflective judgment? We'll be using stepwise multiple regression to examine predictors of lectical growth. This first table shows the average lectical growth between pairs of test times. Average growth between time 1 and time 4 was 0.43 of a level, an average of 0.14 of a level per year. For the analyses that follow, we calculated growth scores by subtracting time 1 scores from time 4 scores. A quick examination of correlations between the LRJA lectical scores and other measures shows moderate to strong relationships with correlations above 0.50 for GPA and the 4 capped scores at times 1 through 3. We're curious about, but cannot yet explain, the higher correlations with capped writing, math, and science scores. This figure shows the linear regression of lectical level with grade for all students at all test times. Here we compare the slope for Glastonbury students with the slope for students in our database that attended low SES public schools. The learning trajectory for Glastonbury students is clearly steeper than for low SES students. And by grade 12, low SES students are performing where Glastonbury students performed in the middle of the 8th grade, a 3 to 5 year advantage for Glastonbury students. In this final figure, we've added the private school students in our database. Glastonbury students have a distinct advantage over these students as well. In grade 12, private school students are performing where Glastonbury students performed in the middle of grade 10, a 1.5 year advantage for Glastonbury students. Now, if we take a look at the learning sequences for deliberation I showed you earlier, we can consider the meaning of the differences observed in the last two figures. The average expected score for graduating Glastonbury students is in phase 10C. For private school students, it is 10B, and for low SES public school students, it's 10A. The task demands of most first-year college curricula are around phase 10D, which is an ideal stretch for the average Glastonbury High School graduate in this sample. Now that we've examined the growth of reflective judgment in our sample of Glastonbury students, we examine predictors of this growth with a series of stepwise multiple regressions. There were 66 students for whom we had complete data for these analyses. First, we looked at the relation between growth and capped and CMT scores and found that these did not predict growth in reflective judgment. We did not include any of the demographic variables because none of them were predictors of growth in reflective judgment. The final model included time 1 lectical scores, GPA, student grade at test time 1, number of language courses, number of languages, and number of language years. As shown in Model 2, after taking the effects of lectical level at time 1, grade at time 1, and GPA into account, 2 language variables were positive predictors of reflective judgment growth. These were the number of different languages taken by students and the number of years during which students had taken languages. This result provides positive support for our hypothesis that language learning has an impact on the development of critical thinking skills. To sum up, we have 2 conclusions. First, the average LRJA scores for Glastonbury School District graduates suggests that on average, Glastonbury graduates have reflective judgment skills that are likely to serve them well in college. Also, both the number of languages studied and number of language years were statistically significant predictors of 4-year growth in reflective judgment skills. Although it is difficult with stepwise regressions to determine the size of such a difference, any increase in the slope of development is bound to confer advantages for future learning. This research has its weaknesses. First, the sample was a convenience sample. No formal sampling procedures were used to select students, and there were no controls. Second, we studied only one population, which makes it impossible to generalize our findings. And finally, the size of the regression sample was quite small. With respect to the next steps, here are a few. To begin with, the data we collected could benefit from more sophisticated modeling of longitudinal results. We're seeking a PhD candidate who would welcome such a challenge. Second, to increase generalizability, it will be necessary to attempt replication in other contexts. And finally, future work could benefit from improved research design with more diverse samples, random assignment, and controls.